Good day, everyone. I am Genti de los Pobres. I'm taking the course Bachelor of Secondary Education, major in Mathematics. Section 5.6, Monotone and Inverse Function. So in 5.6.1 theorem, so let I is a subset of real numbers be an interval, and let f I tends to real number be increasing on I. Suppose that C is an element of I is not an endpoint of I. Then, and I, limits of f as an x approaches to C from the left is equal to supremum of the set f of x colon x is an element of I and x less than C. And number two, um, limits of limit of f as x approaches to C from the right is equal to infimum of the set f of x colon x is an element of I and x greater than C. Proof. So in the first note that if x is an element of I and x less than C, then f of x less than or equal to f of C. Hence, the set f of x colon x is an element of I and x less than C. So which is non-void since C is not an endpoint of I. Is bounded above by f of C. So thus the indicated supremum exists. We denote it by L. So if epsilon greater than 0 is given, so then L minus epsilon is not an upper bound of the set. So hence there exists y sub epsilon is an element of I, and y sub epsilon is less than C, such that L minus epsilon um, less than f of y sub epsilon and less than or equal to L. So since if is increasing, so we deduce that f delta sub epsilon equal by definition of C minus y sub epsilon, and if 0 and if C minus 1 C minus y greater than 0 but less than delta sub epsilon. So then y epsilon then y greater than y epsilon but less than C, so that L minus epsilon less than f of y sub epsilon less than or equal to f of y less than or equal to L. So therefore, the absolute value of f of y minus L less than epsilon when 0 or when C minus y greater than 0 but less than the delta sub epsilon. So since epsilon greater than 0 is an arbitrary, we infer that the number 1 holds. So the proof of number 2 is similar. The next result gives criteria for the continuity of an increasing function f at a point C that is not an endpoint of an interval on which f is defined. And that's all. Thank you.